optical isomer. Okay. So for an optical isomer, there is a condition that there should be, first of all, there should be a chiral carbon present. So this is an important condition for us that there should be a chiral carbon present. And now what is basically a chiral carbon is? Chiral carbon is, so the chiral carbon is the one which is bonded to, which is bonded to four different functional group. Okay, different functional group. Okay, so let me give you an example of the chiral carbon, and that is CCl, and we have this CH3, CH2. This is ethyl basically, and there is OH on this side, while there is CH3 on this side. First of all, I just want to tell you that this kind of sign actually means that it is going out of the paper. Okay, this is bonded out of the paper towards ourself, and this means that it is going towards the paper or into the paper. Is that clear, Sultan?
Yes.
Okay, so why we are calling this as a chiral carbon, as it is bonded to four different functional group. For example, this is chlorine, and this is OH group, this is ethyl group, and this is methyl group. Okay, so this is what we mean by a chiral carbon. So let's see something more related to the chiral one. So now let's first discuss. Now you are able to know that what we mean by chiral carbon, and now we need to see basically what actually is optical isomer is. So optical isomer are basically are two non-superimposed image of each other. What we mean by this thing, just want to tell you that what we mean by this thing. Okay, so we mean that, for example, we have this chiral carbon, which is basically a non-symmetrical one. So I was telling you about this optical isomer. They are basically are two superimposed image of each other. For example, we have this compound, and there is basically chiral carbon that is basically present in the center. So now what happens that if there is a mirror in the middle of it, and the other one is like this C2H5 would go on that side. Okay, that would go on this side, and This one would come, we should also show this with dotted line, and this OH would come at this place, this chloride would remain there, and this would come at this place. So you can see there is just the what happens basically, this molecule has gone on other side. This is the same example if you are putting like two hands. अगर आप दो हाथों को इस तरीके से रखें, like you are putting your right hand on your left hand, then it is the same thing. And you will see that the two thumbs and all the fingers, they are basically non-superimposed. You can't put them on each other. Okay. So this is basically the same thing which is described here. And these two isomers, they are basically called as enantiomer. Sorry, enantiomer. Okay, they are called as enantiomer. Enantiomer. So the existence of these two enantiomer, for let's say this is enantiomer A and this is enantiomer B, and their percentages are basically 50%, and the other also has the percentage of 50%. And when they are basically present in the mixture in some solution, they are basically named to be as racemic mixture. Okay, their mixture name is called to be as racemic mixture. Yes, beta, is that clear?
Yes, what's the definition for enantiomer?
Enantiomer are basically like you can write down the definition for that as well. Simple substances. Let me write that for you as well. So simple which show substances which show optical isomer, they exist as two isomer. So they exist as, they are basically isomers now. So they exist
Yes.
as two isomer called as enantiomer. Okay, so they are basically called as enantiomer. So these are the important information related to optical isomer that we must need to kept in mind. Okay. So basically what enantiomer is, that they are basically the optical isomers are basically two non-superimposed image of each other. I have given you the example of like if you are putting your right hand onto your left hand, then you will see that different fingers will come in contact. So what that does that means? That means that they are basically non-superimposed. Okay. So let's
Okay.
move further. GBT.
Also, I'm still not sure on what a racemic mixture is.
Racemic mixture. Okay. Let me just explain you regarding racemic mixture as well. A solution, you can say that when optically active substances are made in lab. Okay. So when they are optically active substances are made in lab, they occur as a 50-50 mixture. Okay, so they exist as a mixture in which these both enantiomer have equal percentages, okay, equal percentages in the mixture. So they are called as racemic mixture. Mixture. Is that clear, Sultan? So the
Yes.
existence of both of them in the solution, which is basically 50-50%, so they are basically called as enantiomer. So let's
Okay.
discuss some of the, you can say, characteristics of a chiral carbon. Characteristics of chiral carbon. So what are basically those characteristics that carbon should be bonded to four different functional groups, to four different functional groups. And the other thing is that carbon should have sp3 hybridization. We know when it is going to have sp3 hybridization only when it has when it has four single bonds, four single bonds, and their bond angle would be 109.5 degree. So these are basically condition that carbon should have a single bond. If there would be a double bonded carbon, then what do you think? It would be a chiral or not a chiral?
It will not be a chiral.
Chiral, yes. Let me give you an example, which is of glucose C6H12O6. And like for example, this is carbon, this is carbon. There are six carbons. Okay. So now there is a double bond which is present here. This is O, this is H, this is H, this is OH, this is OH, and this is H. This is another hydrogen over here. OH is there, H, and then we have OH, and then we have H here and OH here. This is basically a past paper question as well, okay? So it's important as it is a past paper question. So let's decide which is basically chiral. First of all, let's consider this first carbon. So what do you think? Is it a chiral one or not a chiral one?
Um, I think it's not.
Yes, it's not. The reason is that because it is having a double bond here. Although it is bonded to four different functional group, like although it has three different functional group, it is not bonded to four different functional group as it has a double bond with oxygen. So it is basically not a chiral one. So let's discuss about this carbon. It has one bond like this, one bond which is OH different. So this area is also different for this carbon, and place this whole place is also, you can say, different as well. This whole place is different, okay. Let me just tell you, like this whole place is also different for this one. Is that clear?
Yes.
Okay, so this is basically a chiral one. This is chiral. So we can say second carbon is chiral. Done. We can even mark it with this one. So let's move further and let's see about the third carbon. This is third carbon. It has one H group. Okay, let me just select with some different. It has H group here, OH group here, a complete this group is over there. Okay, and there is C3H2H, like this one is also different. So carbon 3 would also be a chiral.
Chiral.
Yes. Now let's move towards this carbon 4 now, and let's discuss about this carbon 4. So it has this complete structure which is different. At the upside, H group here, OH group, and the complete different structure is here. So this one would also be a chiral.
This will be chiral.
Yes, I'm going to mark them with this one. So let's move further and let's see about the. So it has different HOH and the upper part is different and the lower part is also completely different. So this one would also be a
Chiral.
chiral. Yes. So now you have learned this thing that main condition for a compound to be for a carbon to be a chiral, that is basically it is should be bonded to four different groups. Is that clear?
Okay, but I'm still quite confused on one thing, that how is the carbon 4 and 5 bonded to four different functional groups?
Great. Okay, let me just tell you. Okay. So if the like carbon 4, you have confusion with carbon 4, am I right?
4 and 5, yes.
Okay. So just see here. Let's just mark it with red. This age group is different. This OH is also different. And now this whole part, don't you think so? This whole part is different from this part.
Yes, but on both sides it's just a carbon.
Yes, but you have to consider, this is important thing. You have to consider complete thing here. Complete thing here. Okay, you have to consider a complete here as well. Are you getting my point, Sultan?
Okay, yes.
Yes. So this is the main thing. This is the main confusion you are having at this moment.
Yes,
So,
also one thing,
mhm.
how is just a H a functional group?
uh, H is basically a different atom. The main thing is that it should be bonded to either to different atom or to different functional group. Is that clear? So the
Okay,
condition
yes.
here is the carbon should be bonded, should be bonded either to different atom or different functional group. Is that clear?
Yes, sir.
So now, Sultan, let's move towards question number this chiral this five carbon, fifth carbon, this one. So what do you think? It is chiral or not chiral?
Yes it is.
It is chiral because this part is completely different from this whole part. Now, let's move towards sixth one. Do you think it's chiral?
Um, no, it's not.
It's not chiral because it has been bonded to same two hydrogen atoms. Okay, so sixth one will not be chiral. So here the answer is this, that there are basically how many chiral carbons are present in this molecule? So there are four chiral carbons. Is that clear?
Yes.
Okay, so let's move towards the next question. Now we have another question is like this. We have to find out like how many chiral carbons would be there. there is a double bond at this place, and there is OH group at this place. So let me just draw its structure. If I would be considering this point, so it's carbon. Carbon we know can make a maximum of how many bonds? 4 bonds. So it has double bond on this side, single bond on this side. So how many bonds are left? There is only one hydrogen which is linked at this point because it has already made a bond like this bond, and this bond. So one hydrogen is left here, and there is also a carbon at this place. It has been bonded to two different hydrogen, and it should be basically it is bonded to carbon here. So how many hydrogen should be here? Two.
Hmm.
Now again move towards this part, and here it should be having two hydrogen. Then we are going to move at this part. It should be having one OH group. And then here, carbon. So it is having a double bond. It is having hydrogen here. Okay. And but here the bonds are not completed. So there should be one hydrogen here as well. Is that clear?
Yes.
Okay. So let's move further towards, let's name them one, two. I'm just naming it for my own, you can say, like I can tell you where is first carbon and is it chiral or not. Okay. So I'm just naming it
Okay.
for that purpose. So first of all, let's discuss about first carbon. Yes. Do you think it's chiral?
Um, it's not,
Why?
because it's bonded to two carbons.
No, this is not the reason. The reason is that because there is a double bond over there. You can see this double bond. So
Oh,
let's
yes.
move towards second carbon. It's chiral or not?
It's not because it's bonded to two hydrogens.
Great. Because of two hydrogen. And same third carbon is chiral or not?
No, it's bonded to two hydrogens.
So it's basically not chiral as well. What about fourth carbon? Fifth, we
Fourth,
know, fifth carbon,
uh,
we know it's not chiral because of double bond.
yes.
Okay, so what about fourth one?
Fourth one is chiral.
Yes, that is chiral because it has OH group here, OH group here. And if we move from this place upwards, so it would be having different structure as compared to this one, like this model, or you can say this one. They are basically completely different. So that is why we would be saying that fourth carbon is the only one which is chiral. Okay.
Okay.
So let's move further and let's see some more examples. Okay. So now this is the tricky one. Okay, so now it is basically C double bond C, and there is one C here, H here, and then we are going to have C here, OH here. Okay, and there should be one more hydrogen as well. And now we are going to move here C, so it should be bonded like this. So it should be H, and here it should be H and H. So one, two, three, four, five. So first carbon, is it chiral or not?
No, double bond.
Great. So it is not chiral as it is having a double bond. And what about carbon, these two?
Also, it's not because of the double
Double
bond.
bond. And is it third one, is it chiral or not?
And it's bonded to two hydrogens.
Great. So it's not a chiral one. And what about fifth one? It's not chiral because
This
of
one is not
hmm.
chiral.
So now let's can you please tell me about the fourth one? Is it chiral or not?
Yes.
Acha. I
No, it's not, I think.
okay, if you are saying no, then the reason is that it is bonded to different. And if we are seeing this region here, if we are going towards this part, that is similar to this part as well. Is that clear? That is why
Yes.
we are saying that the fourth is not chiral. Okay, because if we see here, it has the same, you can say, structure as compared to this one. So that is why it is not chiral as well. So there is basically no carbon in this. No carbon is chiral. So let's move further. And now let's see what other things we have. This is CH3. This is double bond O. Now let's first draw the structure double bond O. There is carbon here, so it should be hydrogen here, here hydrogen. And then we have another carbon, should be hydrogen, hydrogen. So carbon, hydrogen, hydrogen. Then we have carbon here, which has this CH3, and it also has hydrogen as well. So then we have this carbon, hydrogen, hydrogen, and now it is linked here. So, first of all, this first one, second, third, let's see, fourth, fifth, and sixth. So, this is chiral, first one,
No.
not chiral. What about the second one?
Also,
Not chiral because of same hydrogen at this place. And what about sixth one?
six bond is no,
Yes,
because of
not
two
chiral.
hydrogens.
So this one, fifth one is also not chiral because of same hydrogen at this place. And fourth one is either not chiral as well. And what about the third one?
The third one is also not chiral.
Why? Why you are saying is it is not chiral?
I think because the fourth one and the second one are the same.
No. I was telling you, like, for example, this is different, this is different. The condition is fulfilled. And now, if you're going to see here, then you can see this part is different, and even this part is also different. You can continue until you find the difference. So that is why I'm saying this carbon third is also chiral, is chiral.
But the fourth one and the second one are both the same.
Wait. Y- but I was saying that you have to continue at this place as well. You have to see like this first one as well. That is different. So fourth and fifth, that would make both of them different as well. You have to continue. This is the thing I was telling you. You have to keep continue. देखिए आपको although you find that this whole is basically same, you are finding that this is same, and the thing is that if they are same, then you have to look forward that whether this is also same. So you have to look forward that whether this is also same. And when you came to this fifth part and when you came to this one part, you have found the difference. So that is why you can say that carbon 3 is chiral because it is bonded to four different groups. Is that,
Okay.
yeah, Sultan, this point is clear?
Yes.
Okay, so I would be saying that this is the only chiral carbon in this structure. ठीक है? Sure. So let's move further and let's discuss something more related to them. Now, there's a complex question as well. And now let's see what we are going to do related to it. Uh, let's see, it's a cholesterol molecule. Let me find that cholesterol molecule. I think it should be available on internet. Mm, mm. Yes, this is basically the picture. Let me just find that picture for you. What this is. Some glitches basically occurring here. Mm, okay. So, okay. So if you can see at this place, so let's discuss about them in detail. So first of all, we know this carbon has basically two hydrogen here, here. So it would not be a chiral. Same is the condition with this one as well, not a chiral. So same is the condition with this as well. It is not chiral as it is bonded like this. So what about this one? Is it a chiral or not? There is H group here, and at this place, if you can see at upper side is different from this downside. So do you think it is a chiral?
It's not.
It's a chiral because if you can see here, if you're moving up at this place and if you're moving from this place, then you will find this thing
Oh,
that
okay.
this is different as well. So I would be saying this is also a chiral. This first one is
So
basically
how far can you continue?
until you find the difference.
Okay.
Yes, until you find the difference. So just so this point is clear to you, Sultan?
Yes.
Okay. So I would be saying that this is the first one, which is chiral. And what about this one? Is it a chiral? No, no. So what about this one? This, please. This has
It's not
been
double bond.
great. So it's not a chiral because of double bond which is present at this place. So let's move to for this point. Is it a chiral or not a chiral? This is carbon, CH3 at upside, C molecules are at this side. So this is also a chiral because it has been bonded to different groups. Okay, because if you can
Okay.
see at this place, this seems to be different as compared to this upside as well. Okay,
Okay. I just want.
so
Okay.
yes, so let's move further. Now let's discuss about this as well, like this place. So what do you think? It is chiral or not?
It is. Yes.
Uh, there is carbon here. Yes, so this one would. Okay, so it's clear to us that this first is carbon, this second is chiral. Okay, and now this one is not chiral because of double bond, and this one is not chiral as well because this carbon is bonded to one hydrogen here and one hydrogen here as well. Okay, although these parts are different, but it has two hydrogens same as well, so it's not uh, chiral. Okay, so let's move about this third part. What do you think? Is it chiral or not?
It um so
This part is different, you know it. And
I
this
think
one,
it is chiral.
yes, it is chiral because this part is also different as well. So now this one, what do you think? This fourth one is chiral or not?
It is chiral.
Yes, so we have seen some of the things as well. Like at the point of junctions, okay, this is point of junction where this benzene is basically attached with another benzene molecule. So you can see that at these points they are chiral. So if we are going to discuss about this place, do you think it's also chiral as well?
Yes.
Yes, it is chiral. So this fifth one will also be chiral as well. What do you think? This sixth one is chiral?
Yes.
Yes, it's chiral. What do you think? This one is chiral?
Yes.
Yes, so it's seventh is also chiral. What do you think? This one is chiral?
Yes.
So eighth is also chiral. So what do you think? This one is also chiral?
No.
This one is not chiral, okay? Because there is carbon and is bonded to this place and this place as well. So it would not be chiral, okay? What do you think? This one is chiral?
No.
Yes, because carbon here is bonded to two hydrogen atoms as well. What do you think? This one is chiral?
No.
Yes, because same it's bonded to two different hydrogen. So this one is chiral. So how many chiral atoms are there in cholesterol molecule?
Um,
I have I have numbered them already.
yes. So the one is chiral, two is
Yes,
chiral,
three is
three
also.
is chiral, four is chiral, five is chiral, six is chiral, seven is chiral, eight is chiral.
So how many chiral are there?
Eight.
Yes, so there are eight chiral carbon present. Okay.
Okay.
So let's move further. Now we are done with this optical isomers, and let's move further towards the concept of alkenes. Okay, so what we mean by basically alkenes, let's discuss them. Alkenes, we know that they are basically hydrocarbons. So alkenes are, so we know that alkenes are hydrocarbons, and we know that what are basically hydrocarbons. Hydrocarbons are basically the compound which contain carbon and hydrogen. Okay, so there are basically, we know that the general first of all, there are hydrocarbons which contain carbon and hydrogen. And the important thing that I just want to tell you, that they are said to be saturated hydrocarbons. Saturated hydrocarbons. Why we are calling them saturated hydrocarbons? Because of having single covalent bond. Okay, so their general formula we know that is, yes, what is the general formula for alkanes?
CnH2n plus 2.
Plus 2. So we know when n is equal to 1, we have got CH4, which is methane. And then when n is equal to 2, then we got C2H6, which is ethane. So we have done this in O levels as well. So this is methane, and this is basically ethane. Now let's move further and let's discuss about the reactions of alkanes. The reactions of alkanes. So first of all, the first reaction of alkanes is combustion. So this combustion occurs in excess of oxygen. So it occurs either in excess of oxygen. So in excess of oxygen, what happens? Like for example, we have this C2H6, which is ethane that reacts with O2 and would be forming always carbon dioxide and water during the combustion process. So let's label them out. So we have to put 2 here and we have to put 3 here. So how many oxygens are on the right hand side? They are 4 plus 3. That would become 7. So we are going to put 7 by 2 here. Is that clear?
Yes.
So this is basically a combustion process. And if this reaction occurs in limited supply of oxygen, then what happens? Carbon monoxide will be produced. Is that clear?
Yes.
So then we are going to have cracking as well. So what we mean by cracking? Like for example, you must know it that basically we know that crude oil is sent to the refinery in which we convert crude oil into certain fractions. Like we make gas from it, we make petrol from it, we make diesel from it, we make kerosene from it, okay, we make naphtha from it, we also make bitumen from it. So now they are basically less demanding. The one on the right hand side, they are less demanding and they are long chain hydrocarbons. They are long chain hydrocarbons. Is that clear, Sultan?
Yes.
So they are basically long chain hydrocarbon and even they are less demanding as well. So these long chain hydrocarbons which have limited use, okay, so they have basically limited use, they are less demanding, they can be converted into more demanding product. This is more demanding product, okay. So this more, they can convert this long chain hydrocarbons and first of all, they are small chain hydrocarbons. And long chain hydrocarbons can be converted into small chain hydrocarbon by the process which is known to be as cracking. Okay, is that clear?
Yes.
Okay, for that purpose, what we are going to do, this process, first of all, this cracking process that basically occurs in absence of oxygen, and there is a catalyst which is basically silicon dioxide, which is also has been used during this process. So in these kind of reactions, so what actually happens, like for example, we are having an alkane, which is long chain hydrocarbon, and we have to convert it into like small chain hydrocarbon, which is C3H8. This is basically alkane. Okay, we can do it like by ourselves, alkane. So this was also an alkane. And now there is also alkene. Like you can make two alkene as well, which have been made C3H6. And you can easily see that these are basically alkene as they are going to have formula CnH2n. Okay, so these are basically alkene. This is also alkene. So this is basically the process of cracking, in which alkane has been converted into another alkane or alkenes. Okay. So there's also it has also the application that it has been used to produce hydrogen as well. Okay, during the production of hydrogen, we also use this cracking technique, which converts C8H18, and hydrogen gas has been eliminated through it. And what happens? There's the production of uh, alkenes. Okay, this is like 3 carbons there, then remaining is 5 carbons and H10. So you have seen this thing that now alkane has been converted by the process of again cracking, and it has been converted into hydrogen. There's elimination of hydrogen over there, and there are basically two alkenes which have been formed. Okay.
Okay.
Now let's move further and let's discuss about the last reaction of alkanes, and that is free radical substitution reaction. Free radical substitution reaction. And this free radical substitution reaction basically occurs with halogens, okay? Like alkane, they basically reacts with halogen, and this reaction occur under the presence of UV light, ultraviolet light. If you are going to do this reaction in dark, then this reaction would not have been taken place. So what they are going to form? They are going to form an halogen alkane with the HCl, okay? Or you can say an acid. Like for example, we are going to have this C2H6, and this halogen, which is chlorine. So it is going to be break, and what happen? One chlorine will react with hydrogen and form HCl, and the remaining would move, you can say at this point or any point that you can choose it by yourself. So a chlorine is going to attach at this place. So it has formed one chloroethane, okay? Or you can say a chloroethane. So this is basically a free radical substitution reaction, and in our next class, we are going to discuss about its mechanism. Okay?
Okay.